the virus is in there based on this, because we are looking for the antibodies against two viral proteins, GP120 and GP24. Remember, if this is really true, then these lines go up and come down as the primary immune response that I told you before, correct? But this is not doing it. These antibodies are staying at a very high titer in high quantities. What it tells us that the virus was there. So, there's a saying, and there are things that sometimes you read or you hear and you never forget. And that is that, I think I was reading a book by Gibran. I don't know how many of you know about it. This famous book is called Prophet. And it is really poetic. And he said, he wasn't a scientist, but this is really a scientific thing. He said, if you can hear only what sound announces, and see only what light reveals, then in fact, neither you hear nor do you see. You have to learn to see what is in between the lines always. And in between the lines here told us that no, this virus is actually still hiding, and now we know it was hiding in the lymph nodes, and we were checking the blood, and in the blood it was absent. So the virus, once it's there is no way you can get rid of it. Another complication with the HIV, and I keep saying this is a bad disease to have, is that at the last stage of the disease, you can have what is called encephalitis and other neurological problems, right? Now, if you really look at it, the virus is in the blood, and the circulation, we have a blood-brain barrier. Only certain things can cross into the brain, other things cannot actually go there. So it's another puzzle. I mean, we have learned it's very unfortunate to have this disease, but on the other hand, we have learned so much from these current viruses, I cannot tell you, right? That how it is going to go into the brain. Right? Now see how smart the virus is. You remember I told you macrophages are the cells which are amoeba-like cells in the non-specific immunity, and what they do, they eat up this thing, but the virus does not die in these cells. It is still replicating at a very slow speed. And the macrophages can easily cross the blood barrier, blood-brain barrier pretty easily. So it's really hiring a taxi cab and say, okay, take me there. And then one of the proteins which is present on the surface of the cell, it's a fusogenic protein of the virus, correct? It's called GP41. So once the infected macrophage goes there and the virus replicates, now it will fuse with a neuron. So we were thinking that the virus is present in the neuron. Yeah, it is in the neuron, but this is the way it actually got into the neurons, right? Now, the transmission, I think it is a kind of a disease you really have to go out of your way to get it. It is not like influenza or something like this. Don't you have to go pick your mother up? Okay. Don't blame me. Okay. See, you have to go out of your way to get this infection, right? So these are some of the ways. If somebody is sharing needles, it is not very good either. Blood transfusion gave us a lot of problems. I was working at the St. Luke Children's Research Hospital from 1985 till 1989. And blood transfusion is normally given at that time. We did not have a test to really test the blood, and a lot of these people got it. So I think my advice is following, that if you have to have blood transfusion, no matter what your surgeon says, few weeks before the surgery you can donate your own blood to the blood bank, and make sure that if they say if blood is needed, they must give you your blood and nobody else's. Now if it's an accident, you are going to die anyway. So there, take the blood, don't refuse it in those cases, right? Then we have transplantation, the same problems that I told you, because we are taking tissue from one person and giving it to another. If the donor is infected, you will get it. And the sex, this is one of the major problems. All kinds of sex, oral sex, vaginal sex, anal sex, and so-called sex, right? Now, you remember earlier I told you that for a microorganism to cause a disease, it has to get into your body through the proper channel. And although mouth is not a proper channel for the HIV, right? But it doesn't mean oral sex is safe, really, because none of us have a perfectly healthy alimentary tract. We have micro ulcers, and sometimes these are so small that only visible microscopically. And these are the inflammatory areas. Same thing which I said, you cut your finger and you can get infection, right? And why is this inflammation? Because the T cells are there. So virus will be picked up right away from the mouth. There is going to be no way that oral sex will be sex. Same is true here, anal sex, because I think the problem there is, no matter what kind of jellies you are using, there is going to be a physical injury. And this is what we faced in the early epidemiology, that these were mainly gay people, male gay people who were really getting this disease. And so it doesn't matter you are a man or a woman, anal sex will cause the damage, and if it causes the damage, there's going to be inflammation, and if there's an inflammation, the virus is going to be picked up pretty easily, right? This is a misnomer term. There is absolutely nothing that you can call safe sex, unless, there's a TV channel, what they call it, DIY, you know that? Yeah. You can call it sex. And even, apart from that, you can just say, okay, it's very safe to use the condom. You know what? You can use a condom, but Murphy's law is that condom is going to break down at a very critical time when you least expect it. So you use 2 condoms, safer than 1, then 3 or 4, then 1. You know what I'm saying? So really, there is absolutely no safe sex at all. But I think what we are doing is we are fighting against biology. Let me go through this and I will stay with the epidemiology for the next 5 minutes, right? So look at this. This is the very first time we saw 12 cases in a New York, 75%. And see how these numbers are increasing enormously. And this is really misleading in many, many ways. Because although in the last slide I will tell you that we have a lot of antiviral drugs, there's absolutely no doubt about it. This again gives you the idea that how quickly the virus is spreading around the globe. This is some of the data from the WHO, World Health Organization, right? And I think this is misleading that it is really coming down, because what happens is it's a constant evolution. AZT was the very first drug which was given for the HIV, and I am not kidding. After we gave AZT to the person who was suffering from the HIV, 3 days later, we can isolate a mutant of the virus which is resistant to AZT. Now we have multiple drugs, and we use a combination of several drugs in order to treat it. So we are really prolonging the life, but it's also a matter of time, because we saw with other microorganisms what happened. One of them is called Mycobacterium tuberculosis, the bacterium that causes tuberculosis, right? Now we are seeing the strains of tuberculosis which are resistant to everything. We have the bacteria which is resistant to every darn drug which is available to us, right? So it's really the matter of time, and microorganisms will be resistant no matter what drugs. They are much smarter than we think. And this is the distribution of the HIV cases around the globe. Now for the treatment, what we do is, I think the best way, the reason we are successful in treating certain things, penicillin is very good. It will take care of it very nicely, whatever bacterial infection you have. And for viruses, we don't have any effective antiviral drugs. For HIV, a lot of them don't. What we do, the basic principle is that we target either molecules or processes which are uniquely present in the virus and absent in the human being. So that way you are not going to have the side effects. So penicillin doesn't have any side effects. Allergy is a different story, okay? Because it interferes with the cell wall of the bacterium, and we